Hi, Dhruva. This is Mike DeVore, or Mr. DeVore. And I wanted to go over the questions that you answered on or asked about on the questionnaire, just so you can kind of have an idea of how I'll go over certain questions. Like if you throw a question at me, maybe it's a homework question or a test question, sometime during the week, often I'll make just a real quick video and go over it. And hopefully that'll help you. Like before we come up on our sessions, you'll be able to ask good questions, and hopefully I'll be able to give productive answers. So, okay, so this is one of the questions you asked about. So let's look at this. Okay, so we have a figure here. Okay, write the rule. Okay, hold on here. Using correct explicit notation. Okay, so right off the bat, that's leading me to believe that explicit sequence generators, that this is going to have something to do with a sequence. Okay, explain using complete sentences, blah, blah, blah. And then find how many squares exist in figure 140. So the 140th, right? So if we were going all the way over to here, so number 140. Okay, so first let's just take a look and see what's going on here. And when I look at these figures, first thing I notice is they're getting bigger. Okay, they all have this same sort of like Z pattern, right? So I'm going to predict that our number 4 over here would just be a bigger Z thing, right? So it would look maybe more like that. Now, I see it's growing. I'm going to come back and look at this maybe in a little bit more detail now. And as I look at this, I see that what's happening on all of these, they have this same little, here, let's do that. These little corners here, right? This corner here, right? So that's one thing they have all these in common. So we're not getting any more corners, but we're getting these, like, I guess we can call like little legs off of them, right? So let's look at this first one here. Like we have 2. Then I look at figure 2 has 3. Figure 3 has 4. So I'm going to go ahead and guess that like if we had a figure 4, it would have 5 of those. 1, 2, 3, 4, 5. And I'm going to put my little that corner box thing here. Okay. And I know I have another corner box down over here, so I'm going to go ahead and put that in there as well. Okay. Now let's go to this middle section here. I have a 1 here, 2, 1, 2, 3. So I'm going to go ahead and out on a limb and say 4, right? 1, 2, 3, 4. That pattern looks like that holds. Now come down here. I have a 1, 1, 2, 1, 2, 3, 2, 3, 4. Okay. So I'm fairly confident that that's what number 4 would look like, just, generating this pattern here. Now, let's look at it another way. We looked at it like visually here, but now let's look at it actually numerically, okay? So what they want to know is how many squares exist for figure 40. So if we're going to write an explicit notation, we're going to write a rule that determines how many of those squares that's linked with what figure, okay? So in my first figure, so I'm going to use n for our figure. So figure 1, I have 1, 2, 3, 4, 5, I have 6. Okay, so number of squares, 6, okay? So in figure 2, well, remember I have one more up here, right? And I had one more here in this middle one, I had one more there. So there's going to be 9. So if I were to count that up, I'm pretty sure there would be 9. Then here, there's just one more each at this top here, plus 1, plus 1, plus 1. Okay, so in this third one, there should be 12. I've done that right. And I'll just go ahead out to that fourth one, 15. So if we counted up all these, we should get to 15. So maybe you recognize what's going on now pretty quickly, right? We have 6, 9, 12, 15. So I think you see the pattern here, right? We're just adding 3 to each one. And essentially what you've done, and I'm sure you recognize this now, is this is just an arithmetic sequence. Okay, in an arithmetic sequence, we can predict what's going to happen. Okay, so I can tell what the 4th, the 5th, and so forth. But as far as finding the 140th, I don't want to just keep adding 3. That would take me forever. So what we want to do is have an explicit sequence generator, and it depends on how your teacher has referenced it, whether it's he calls it a function or not, but a sequence generator. Okay, so I know that you use the CPM book, so I'm pretty sure the CPM book uses this sort of notation. So for any nth, for the value of any nth term, we need the value of the first term plus the common difference n minus 1. Okay. Now, this is one way to write it. Most of the books actually don't write it like this, but if you're comfortable with this, that's good. So let's go ahead and fill in what we know. Okay. So just for the any nth term, my first term, well, that's 6, right? So I'm going to go ahead and put that 6 here. Plus, well, my common difference is 3 n minus 1. So technically, you're done with that for top part, correct explicit notation. So this would be correct. Now, perhaps your teacher says, well, I want it more simplified. And that's okay. We'll simplify that just by go ahead and distribute this. So we'll have 6 plus 3n minus 3. And then we'll finish that off. And I'm going to do this, okay? I'm just going to move this variable term up here. And now you would definitely be happy with this. So there's your explicit sequence generator that would generate any individual value in that sequence. So, oops, get rid of that. So let's just test it once, okay? So at 3 here, I'm supposed to have what? 12, right? So I'm supposed to have 12. So if I put in a 3 into here, t of 3 equals 3 times 3 plus 3. So of course that does equal 12. Looking pretty good. Okay. So finally, what would it, how many tiles would be, or squares rather, would exist in that 140th? We'll just plug in 140. So we would go T140. It's 3 times 140 plus 3. So what would that give us? Let's see, 300, 423, 423. And that's how we would find that. Now, as far as using the complete sentences up here, just explain how you would recognize this pattern as an arithmetic progression or arithmetic sequence, depending on the vocabulary that your teacher uses. And once you realize this, you knew how to find the explicit sequence generator, and that's this part here. Okay, and then you just went from there. So hopefully this helped, and I'll go ahead and make another quick video for your next question. Okay.